the problem that I was talking about during today's meeting. And this problem is in the material the Sendil sir has sent you, the MCQ material, and this is the first problem in that material. Let me read that out first. A ray of light incident at an angle theta on a refracting face of a prism emerges from the other face normally. If the angle of the prism is 5 degrees and the prism is made of a material of refractive index 1.5, then the angle of incidence is, there are 4 options, A 7.5 degrees, B 5 degrees, C 15 degrees, and then D 2.5 degrees. Okay, what does it say? You have a prism, you have a triangular prism. So light enters through the prism from one side and then it emerges from the opposite side. And when it emerges normally. Okay, so if you draw a normal to the surface from the point where it emerges, then the light that emerges is along the normal. If that is the case, then they are asking you to find out the angle of incidence on this side. They are given you the refractive index of the prism. Let's start with what we know about it. What we know about the triangular prism. Well, you have a prism like this. So this will be the angle of the prism, A. Okay, a light can enter, a ray can enter this prism from this face. There I can draw a normal and I will have an angle of incidence I. Then there would be an angle of refraction like this. So this would be my R1. I call this as R1. This is actually angle of refraction. And this will hit this face at this point. So if I draw a normal, then I'll call this as R2. Even though I call it as R2, it is actually the angle of incidence for this face. And there is a normal, so there will be an angle of refraction on the other side, which I will also call as the angle of emergence considering the prism as a whole. So this E is actually the angle of refraction for this face. But if we consider the entire prism as one single thing, then this is where it enters, this is where it emerges. So this is angle of incidence and that is angle of emergence. Okay. So what do we know? I can consider this quadrilateral. This and this quadrilateral. So the sum of the angles of the quadrilateral would be 360 degrees. Right? And we also know that this angle is 90 degrees, this angle is 90 degrees because they are found by the normals actually. So this angle is 90, this angle is 90, which means that this angle plus this angle, I will call it as Q. Angle A plus angle Q must be equal to 180 degrees. That is considering the quadrilateral here. So as far as the quadrilateral is concerned, A plus Q must be equal to 180 degrees. Now I am going to consider this triangle also. This triangle. R1, R2 plus Q must be equal to 180 degrees. So R1 plus R2 plus Q must be equal to 180 degrees. Which means that R1 plus R2 must be equal to A. So this is what we know about this prism. Now let's come to the question. You have the prism here. So this is A, which is equal to 5 degrees. That's given. They say that light emerges along the normal, this is, suppose if the light is emerging from this point, then I can draw a normal. The light is actually emerging like that, okay, along the normal. So what do you know when light emerges through the normal? When will light emerge through the normal? Only when it is coming through the normal will it go through the normal without any refraction. In that case, sin I is equal to 0, I must be equal to 0, then sin R is also equal to 0. So the refractive index will become 0 by 0, indeterminate, we talked about it. So 0 by 0 doesn't mean that, the indeterminate doesn't mean that the value does not exist, but then you are not able to find it using this condition. That's what we discussed before. Let's forget that. So the bottom line is, if something has to go through the normal, it must have entered through the normal. Then it will go through the normal without any refraction. Okay. So if this is coming out normally from this surface, which means that it must have entered the surface also normally. It must have entered the surface also normally. Well, but here, this point, if I take this point, there is a normal I can draw to this surface, and then there could be an angle of incidence for this. Maybe something like this. It should go on there, it goes like that. So this would be my angle of incidence I. Okay. So light enters like this, then gets refracted, but then that becomes normal to this surface, so it just comes out of the surface normally. So that's what it is. Okay. So which means that what is R2 here? R2 must be 0, right? R2 is the angle between the normal and the incident ray. But here, the incident ray is a normal actually. It goes through the normal. So the angle between the incident ray and the normal is 0. So R2 in this case is actually 0. But what do we know? We know that R1 plus R2 must be equal to A. If R2 is 0, then R1 must be equal to 0. So this R1 must be equal to A. That's what we know. Once we know this, then the rest is easy. Why? Because what is the refractive index? Mu written as sin I by sin R1. But R1 is A. So what I get here? I get this sin I by sin A is equal to mu. So what is sin I? Sin I is equal to mu times sin A. So I is equal to sin inverse of mu sin A, which means I is equal to sin inverse of 1.5 times sin 5 degrees. If you have the plots table book, then you can find the value of sin 5 degrees from that book, going through the sine table. And then multiply that with 1.5, so we'll get some value. And if we go to the sine inverse table in the same plots table book, then you can find the value of I. Okay? Or if you want to leave it like this, that is also fine. But you can find the value of sin 5, multiply that with sin 1.5, so we'll get some number. Take that number, go to the sine inverse table in the plots table book, then find the value of sine inverse of that number, and that will give you I. If you do it, it turns out that I is actually 7.5 degrees. And if you don't have the tables, forget it. You don't have to worry about the final step. But up till here, should be fine. If you don't have access to those tables, then leave it like this, that's also fine. But this is how you do this problem. Hope this is clear to you.